So, ladies and gentlemen, you are welcome to my YouTube channel. In today's video, we are going to look at the concept of nuclear chemistry. And if you want to follow us for more videos and content, please follow us on radioactive.com.ng. So now let's look at the concept of nuclear reaction. So nuclear reaction is a process whereby the nucleus of one atom interacts with another nucleus or particles leading to formation of one or more nuclides. So in a nuclear reaction is a type of reaction whereby the nucleus of one atom interact with the nucleus of another atom or a particle. And that leads to the formation of the new atom or new nuclides, which can be one or more than one. So it can lead to the formation of one or two or more nuclides. So therefore, in a simple term, in a nuclear reaction, it's a type of reaction where the nucleus of one atom interact with another atom, a nucleus of an atom interact with a particle. And the particle can be neutrons, can be protons, can be alpha particles, can be gamma particles, can be electron capture. So when the nucleus of one atom interact with a particle, then it leads to the formation of a new atom, different atoms from the original one. So, like for example, look at this case here. We have uranium-235 interact with a neutrons. So it means that in this case, the neutrons here interact with the nuclides of uranium-235, which leads to the formation of uranium-236. So in this case, the uranium-235 is a stable nuclide. But when bombarding it or when it interacts with the neutrons, it now become unstable. So due to that instability, then the nucleus of uranium-236 start breaking down to generate more nuclides. And of course, here you can see that two more nuclides are generated. This is krypton with a mass number of 92, and this is barium with a mass number of 142. And of course, in the process of this nuclear reaction, a huge amount of energy are generated with 3 molecules of neutrons. So in a nuclear reactions, ladies and gentlemen, a simple term is a type of reaction where the nuclide of one atom interact with another nuclide, leading to the formation of more nuclides. Like in this case, krypton and barium were generated with a huge amount of energy, and also 3 molecules of neutrons are also generated. So that is nuclear reaction in a simple term. The nuclei of one atom interact with a nuclide of another atom or interact with the particles, which leads to the formation of more atomic nuclides. And as I said, the particle that I use in interacting this nuclide can be neutrons, as in this case, can be alpha particles, can be gamma particles, can be beta particles, can be electron capture. And we have so many of them. So that is nuclear reaction. So now the next thing that we are going to look at is different types of nuclear reaction. So we have different types of nuclear reaction, which include nuclear fusion, radioactive decay, nuclear transmutation, elastic and inelastic scattering, and then electron or a capture reaction. So let's start with a nuclear fission. So when you say nuclear fission, is a reaction that involves splitting a heavy nucleus into 2 lighter nuclei, releasing a significant amount of energy. And it is used in nuclear power plant and atomic bombs. So in nuclear fission, what actually happened is that we have a heavy atom, we have a big atom. we have a very heavy nucleus, that a very big radioactive element which actually split or break down to produce smaller one. So like for example, in this case, we have uranium-235. In the presence of neutrons, then it now splits or break down to generate barium 1 with 1 and krypton 92. So you see here we have a heavier atom with a mass of 235, which actually subsequently break down to generate smaller nuclei. So that is what happened in the case of nuclear fission. A large amount of energy is generated where heavier atoms break down to generate smaller ones. So therefore, in a nuclear fission, smaller atoms are liberated from heavier ones with the release of huge amount of energy. That is nuclear fission. And then the next one that we are now going to look at apart from nuclear fission is nuclear fusion. So in the case of nuclear fusion, is a reaction that combines two lighter nuclei to form a heavier nucleus, also releasing energy. So fusion powers the sun and other stars and is being searched for clean energy solutions. So therefore, in a simple term, in a nuclear fusion is a types of nuclear reaction which is smaller atoms or a light nuclide combine or joint to form a bigger ones with release with a huge amount of energy released. So now let's look at it. So in this case, we have deuterium as a lighter atom. We have tritium as a lighter atom. So they fused together through a fusion reaction to generate a large helium nuclei. And of course, with the release of neutrons. So in this case, you see we have a lighter atom, that is smaller atoms, deuterium and tritiums. They combined together to generate a heavier nuclei. And of course, a huge amount of energy are released during nuclear fission. So in nuclear fission, smaller atoms join together to generate a larger one with the release of neutrons and energy. So these are the products that are generated during nuclear fission. Smaller atoms join together to generate a bigger one. So, and then the next things that we are going to look at under nuclear fission is radioactive decay under nuclear reaction. So, in this process, an unstable nucleus emits radiation and transform into a different nucleus. So, and there are different types of radioactive decay, including alpha decay, beta decay, and gamma decay. So, and a radioactive decay is a process whereby an unstable nucleus break down on their own, because radioactive decay is usually a spontaneous disintegration, because the atoms generally have unstable nucleus. So once the nucleus is unstable, then the element will now start undergoing rapid breaking down to emit radiation. And in the process of emitting that radiations, it's transformed into a different nuclides or into different nucleus. And we have different types of this radioactive decay. So in radioactive decay, there are atoms on their own because their nucleus are unstable. So they will start undergoing self-breaking down to emit radiations with a huge amount of energy, and in the process, a new or a different nucleus or a different atoms are generated. So, as we said, we have different types of radioactive decay. We have alpha decay, beta decay, gamma decay. We also have positron-electron capture. We have positron emission, and we have electron capture. So let's start with alpha emission. So whenever you have a radioactive substances or an unstable nucleus, so when it undergo an alpha decay, it means that a helium atoms are generated, or helium's atoms are emitted as a radiation or as a particle. So whenever you have an alpha decay, it means that the mass of the unstable nucleus will reduce by 4 and the atomic number will reduce by 2. And that is why here we have A minus 4. It means that the mass number is reduced by 4. And we have Z minus 2, meaning that the atomic number will be decreased by 2 because the helium nucleus here is an alpha that was actually emitted during the decay. And then we have a beta decay. So in the case of beta decay, of course, an electron is sort of presented as a beta decay with a mass of 0 and atomic number of -1. So that is why whenever you have a beta decay, so the mass number always remains the same. So that is why here we have A. And of course, the atomic number always increases by 1. So that is why here we have Z plus 1. So in a beta decay, electrons generally are used in representing it. And of course, the atomic number of the original element usually increase with +1. And then the gamma decay, which is the next types of the radioactive decay. So in this case, the gamma decay, mass number and atomic number remain unchanged. That's why here we have A and Z. So because the mass number and the atomic number remain unchanged. And of course here we have gamma. So in the case of gamma, the mass number and atomic number doesn't change. So the next thing under this is, of course, electron capture. Electron capture is a process in which the proton-rich nucleus of an electrically neutral atom absorb an inner atomic electron, usually from K or L electron shells. In the case of electron capture, because the nucleus is highly rich in protons and the elements or the atoms are electrically neutral, so they tend to actually absorb atomic electrons from the inner shell, which are usually from either K shell or L shell. This is what actually happened. So like for example, in this case, this is the nucleus. This is the nucleus, and of course it is highly rich in proton. So then this nucleus tend to now absorb the inner electrons. This is a K shell, so it can actually intend to absorb the electrons here, or from this is a K shell, or it can actually absorb it from L shell. So electrons can be absorbed from either L shell or K shell, so it captured. And of course, look at it, this is a protons, that is the nucleus, and then this is the electrons. So the electrons are captured. So in the electrons capture, usually electrons are captured by the inner nucleus due to the highly rich in protons, and usually in this process a protons is converted into neutrons. You see, this is a proton and then it's now converted into neutron. This Z here is neutron. Of course, you know that neutron have a mass number of 1 and atomic number of 0. So you see, in the process of this electron capture, the protons are converted into neutrons. So this is actually in the case of radioactive decay, which is the third type of nuclear reaction. So the next thing now that we are going to look at after radioactive decay is natural nuclear transmutation. So in nuclear transmutation, this involves changing one electron into another by bombarding it with particles. So in nuclear transmutation, generally the atom is stable, but bombarding it with the particles, it changes into unstable one, which actually undergo, or which subsequently undergo, a rapid breaking down. So like for example, the first time that this nuclear transmutation was conducted is by Ernest Rutherford. Of course, if you now look at the nitrogen here, is having a stable nucleus, but of course, and it's Rutherford bombarded these neutrons, sorry, these nitrogen with the helium particles, and once that happened, then it now become unstable. So therefore, the neutrons is now converted into oxygen, and that is what happened in nuclear transmutation. So in nuclear transmutation, if particles are bombarded or are used in bombarding a stable nucleus, which actually undergo rapid breaking down. So these types of or this nuclear transmutation can occur naturally or can be induced artificially in particles accelerators. Let's look at another example where we have nitrogen, so the neutrons bombarded uranium-235, and of course it now become unstable. So initially uranium-235 is stable, but bombarding it with particles here, which is neutrons, is now become unstable, making it to become 236, and it is now unstable, and as a result of that, a huge amount of energy are generated. 1 molecules of krypton and barium are generated, as well as 3 molecules of neutrons. So these are, ladies and gentlemen, the different types of nuclear transmutation, and the different types of nuclear reactions, and they are very, very important in understanding the concept of radioactivity. And please, if this is the first time you are coming to my YouTube channel, please subscribe. Thank you.